Good morning, students. Welcome to fourth session of first chapter of second part, that is probability. Next type of event is union of two events. If A and B, these two are subsets of finite sample space U, then the set formed by the elements belonging to A or B or both is said to be union of two events, which is denoted by A union B this way. Now let us discuss first with example this, then it will be clear. Now here in this, as previous which example we have taken, that is 1 6-face dice. So possible outcomes from 1 to 6 only. Now event A is, that is 1, 2 and 3, while event B is 3, 4, 5 and 6. So here you can see 1, 2, and because of 3 is common in both, so we write here, and 4, 5 and 6. So this way 1, 2, 3, 4, 5, 6. This is only called A union B. So here A union B will be 1, 2, 3, 4, 5 and 6. Now here it is given what? That the set formed by the elements belonging to A or belonging to B or both, that is called union of two events. Now this will be more clear with one more example. Which example? Even in intersection of two events, in that also we had taken. That is, event A is that one boy, he plays cricket. Event B is that same boy, he plays hockey. Now here union of that is that he plays cricket, that is event A, or he plays hockey, or that same boy, he plays both the games, that is cricket as well as hockey, that is union of two events. Now remember this. In question, if it comes at least word that shows that union of two events, it is there, and where the word comes and A and B, this way two different events, then in that case that is called intersection. Now if both are there, then to okay, A union B will be there, but at least A or at least B, in that case it is A union B. How? Now for that, like here just now which example we discussed, that event A is that boy plays cricket. Now B is that same boy plays hockey. Now same boy, this is, you can say that this is cricket, and this B, that is hockey. Now if, because of boy is same, if he plays only cricket, that is A only if it comes, because of B also is a part of A only, so in that case, if that boy, he plays only cricket, then also it is called union of two events, because boy is same. Same way, if he plays hockey, then also it is to be called as union of two events, because that boy is common for A as well as B event. Here, if it is given that one boy, he plays cricket, that is event A, and another boy, he plays hockey, that is event B, then this union won't be this way. But because of same boy, cricket as well as hockey, both games he plays, or only cricket he plays, or only hockey also plays, then in that case it is called as union of two events. So remember, where the word comes at least, it means it is of union of two events. Means A union B you are supposed to find. And when A and B, this way word comes, in that case it is intersection of two events, that is A intersection B. That way we will solve the sums accordingly. Our next is, that is exhaustive event. Now what is this exhaustive event? The events formed by all the subsets of a finite sample space U are said to be exhaustive events. Now this, remember, this exhaustive event without any diagram, this will be A union B is equal to U, or A union B union C. When three events are there, A, B, C, then A union B union C will be U, and two events are there, then A union B is equal to U. Let us first discuss with example, then it will be clear to you. Now see, here if I take the example, it is this way, that two coins are tossed together. In that case, A will be what? When two coins are tossed together, in that case A is that getting two heads, so it will be HH. Even B is what? That one head and one tail. In that case, first head and second coin tail comes, or first coin tail comes and second coin head comes. And even C is what? That both coins tail only comes. Now we know very well U is what in this? These four only, HH, HT, TH and TT. These are the four possible outcomes, and you can see in A first, B that second and third element, and C that is TT. All four sample points of sample space U, here A, B, C, in that it is there. So exhaustive event is what? Here you can see A union B union C is equal to U. Here A, B, C, these all only are equal to U only. So this is known as exhaustive event. This even when we solve sums, that in that sum also it will be asked the question this way, whether the event is exhaustive or not, or sometimes it will be given this way, that it is an exhaustive event. So it is understood that A union B union C is equal to U. You have to remember this way, A union B union C is equal to U. That means A, B, C, all the three events, all possible outcomes of sample space U are in this A, B and C. This way, this is known as exhaustive event. Now next is, that is mutually exclusive event. Now what is that? Mutually exclusive event. If U is a finite sample space and A and B are two subsets of the sample space U, if A intersection B is null set, then A and B are said to be mutually exclusive event. Now in this, it's very simple. A and B, when they don't occur together, then only, or you can say that between A and B, nothing is common. That is known as mutually exclusive event. Now here if I take the example that event A is same, I am taking of 6 piece dice is thrown, and this is 4, 5 and 6. So 1, 2 and 3, and this is 4, 5, 6. Event A is that number comes 1, 2, 3, B is 4, 5, 6. So in that case, nothing is common. When event A occurs, that time event B won't occur. When event B occurs, event A doesn't occur. So that is known as mutually exclusive event, or very simple to remember. Exhaustive event, A union B is equal to U, and mutually exclusive, nothing is common. Both are independent events, A as well as B. They are not dependent on each other. So that is called A intersection B is null set. So that is called as mutually exclusive event. view, that is different events. Now these different events are two. One is A dash B, another is B dash A. Now let us discuss first, that is A dash B, that is difference event of A. We call this way difference event of A. Now what is this difference event of A? If U is a finite sample space and A and B are two subsets, then the set of elements which are in A but not in B, that is said to be difference event of A, which is denoted by A dash B, or another name of this is A intersection B dash. Now first let us discuss with example. I am taking same example where 1 6 face dice is thrown. So 1 2 3 4 5 6 these numbers are. Now say example event A is that 1 2 and 3 and 4. These 4 numbers are with A, and B, that is 4 5 and 6. Now if I write here 1 2 3 and 4, because of common in A as well as B, so I write here, and here is 5 and 6. Now A dash B means the elements which are only in A, you can say. Here it is given, just now I read the definition. What I said, that the elements which are in A but not in B, that means only in A. So only in A 1 2 and 3, not 4. Why? Because 4 is in B also. So difference event of A will be what? 1 2 3. Is it clear? See, 4 we won't take because of in B event 4 is there, as well as in A also 4 is there, and we want only elements which are in A. So in A 1 2 3 elements are there, so this is known as difference event of A. Now another formula for this also, very easy to remember. See, it is A intersection B dash. What is that? Total A, from that we subtract this A intersection B. So what left is, that is A dash B, which we call it difference event of A. Now in this only, next is, that is B dash A. Now what is this B dash A? Completely opposite to this A dash B. That is the elements which are in B but not in A. That is known as difference event of B. Now same example I am taking. U is 1 to 6 numbers, event A is 1 2 3 4, and B is 4 5 6. So here if I write 1 2 3, here 4, and this is 5 and 6. Now what we want, the elements which are only in B, that is 5 and 6 only, not 4. So here difference event of B will be 5 and 6. Remember, we have to highlight this portion, not of here A. Same with this also, because of it is difference event of A, so we show with A only highlighting, and here with B we show or we highlight it. Now here formula for this difference event of B dash A, we call it difference event of B, that is B intersection A dash. How we find? From this total B we subtract A intersection B, we get the elements which are only in B. This is known as difference event of B. Normally in board, either A by B or B dash A, normally they ask whenever terms are there. So very, very, very important. Last term, that is primary event or elementary event. Now what is that? The events of all singleton subset of a finite sample space U are called primary event or elementary events. Remember, the union of these primary event is U and intersection of primary event is null set. So A union B is equal to U and A intersection B is null set. This way it will be. Now it will be more clear if we take example. Now here example I am taking that one coin is tossed to, so what possible outcomes U will be H or T only because of one coin is there. Now event A, that head comes, and event B, that tail comes. So here all possible outcomes of sample space U, single we take head or tail, or same way if one 6 face dice is thrown, then 1 to 6 numbers individually, single 1 2 3, this is A B C D. This way when you take, then all these individual or single elements, that is events, that is known as primary events. Now remember, A union B, that is U only, you can see H and T, that is U, and always nothing will be common between these events A and B, nothing will be common, so A intersection B will be null set. So remember, union of primary events, that is U, and intersection of primary events is always null set. So primary events are always exhaustive and mutually exclusive events. Both point of view, this primary event is not important definition, but when we solve the sums and word comes primary, so you should know what is primary event or elementary event. So today's session, we did theory part, these terms, definitions with Venn diagram, very important. Now today's homework is all these definitions you write in your notebook along with Venn diagram. So this is an end of this session. See you in next session tomorrow. Thank you.